Hey everybody, welcome back to the shop. I'm about to begin my next machining project. This is going to be a manual machining job that we're going to do. I know you guys have been enjoying seeing all that content, so we're going to knock this out over on our Precision Matthews lathe. So what we have to make here is what we're calling an injection mold die. This is going to be a 3-piece part that we're making. I've got 3 prints here showing each piece. The first one I'm calling the flange. It's got a stem on it there. The second part is actually the sleeve. That's going to be in the center. And in the third part, you have a flange on the end right there. All 3 of these are going to fit together. You have some registered fits where they all kind of align together. And what that's going to end up making is, this is a negative of what's going to be a polyurethane bushing. I believe that's what they're going to be using, is polyurethane. And so if you look right here, this kind of shows the shape of the bushing that's going to be in there. Okay, so this is a job that I'm doing for Justin, also known as the Fabrication Series on YouTube and Instagram. He's also a friend of mine, lives out there in Las Vegas, and has some great businesses out there. Weld Metals Online, that's his business. And this is something that I believe he wants to get into, is start making some different bushings of different sizes. And I believe they're going to be sort of like a universal bushing that they could be used for different applications. But this is going to be a prototype to kick things off, and I'm going to help him with the machining. We do have a few tight tolerances to land on this, and that is mostly going to be these registered fits where the 3 pieces actually kind of fit together, and those registered fits hold together with a very close tolerance. And then the way that he's going to be holding them all 3 together, you have a 3/8 diameter hole that goes through the middle, and he's just going to put a bolt in there to hold those together. And then to inject the polyurethane, it's going to be using those 2 holes right there. I don't really know what he's going to be using to put that in there, but he says that's what the 2 holes are for. I'm not really sure. Something like a syringe that he's going to pump it in there. I'm not really sure. But anyway, this is going to be a first prototype, and he possibly might have some other sizes that he's going to need help with along the way. And this is what we're going to start with here. So what we have is some 1045 steel. This is some cutouts here of a piece of 2.5-inch chrome plated rod. This is what you use to make hydraulic rods, sometimes known as piston rods. And this is just a drop that I had. That was the end of it. And going to work perfect for stuff like this right here. So we've got a piece cut for the flange. We have a piece cut for the center sleeve or the center spacer. All right, and then we have this piece here that's going to be the flange portion of it. So Justin actually drew this up using a different CAD software, and he had sent me the 3 step files. And what I did is I dropped those into Fusion 360 so that I could actually measure it and see what the dimensions were of everything. And then I ended up making these 3 prints. So these are prints that I made myself. I know they're not perfect, they're not industry standard, but what they are is a print that I know that I can look at. It's giving me all the dimensions that I need to know to machine these 3 parts right here, okay? So just wanted to point that out. I just tried to put on there things that I need to know and tried not to jumble it up too much. So we've got the side view, the front view, and that should have everything that I need to work with there. So the tightest tolerances are going to be the flanges there where everything fits together, but it shouldn't be a problem. So we'll go over on to the Precision Matthews lathe and go ahead and get started with it. We'll probably start with this guy right here first and get rolling on it. I'll be using our 3-jaw chuck for this job here. Should work pretty good. And by the way, something that I want to point out is I recently started running the MK Morse bandsaw blade with the carbide teeth, and I'm really loving the cut quality of that bandsaw blade. It's just nice and smooth and square. So anyway, that's something I've been paying attention to since I put that blade on a couple months ago. And I don't have a lot of material to work with here. I gave myself about an extra 1/4 inch that will end up facing off the back side of this thing once we get the long area turned. And what I'm doing is I just snug that up, and it's probably not going to be running really true out here, so we're going to bump it around. Put our dial indicator on it and see what it's doing. Yep, you got a little bit, so just bump that. Just use a little soft blow. Just give it a few taps on the high side there. That's within a thousandths right there. See, went too far. Keep screwing around with it. A lot of times you just end up chasing your tail. That's good enough. That's within a thousandth. So now we're going to go ahead and retighten the chuck. I'm going to go ahead and tighten all 3 pinions. And I'll probably go ahead and, we got to put a hole down through there, but I don't want to do that yet because of the diameter we're going to turn down to. We'll probably just go ahead and face it, put a center in there, and we'll use a live center to help support this while we get all that rough down. Those facers are running nice and straight for a bandsaw cut. Just want to clean it up. Take about 10 thou. Let's see if that'll clean it up. Went ahead and reset our 0. All right, ready to start turning this down. We've got our Z0 set. I've also got this dial indicator over here set to a 0. I like using this down here because when you're standing here at the machine and you're looking down watching this cut, it's a very natural movement to just look right down there and see the dial versus looking up here at the digital readout. I'll show you what I'm talking about. So we've got our Z set, and all I'm trying to say is that when you're standing here just like this, looking at your part, and you're coming up to that shoulder right there, I like being able to just reference a 0, which is the same thing as our 0 up there, but you got to move your eyes up there and get it off of your workpiece. So I just like using both of those to my advantage. So we'll go ahead and we got to take 3/4 off of that. And typically what I do on this machine is 100 thousandths a pass. And the reason is that it's just simply easy to take, to keep up with. Yeah, you could take 200, but it just doesn't seem to really like it, and I don't want to risk pushing this chrome-plated bar stock back in the chuck and losing my position. So 100 thousandths, we've already got it set to a 0, so I usually just do 1, and then the next pass we go back to 0. Just really easy to keep up with, and it won't take hardly any time at all. We'll be down there on our size. That's looking good. should put us somewhere around 0.9 inches. Yeah. So we've got 145 thou to take off that. So one more little rough pass. I'm going to leave that a little bit oversized while we get all of this, all these face features roughed in there, and then we'll come back and make a finished pass across that later. Next thing I want to do is go ahead and get this shoulder machined out here, and I'm going to go ahead and put some of this blue highlighter on there so it's a little bit easier to see. I've already got my tool set at 450 thousandths. That's going to be a 2-inch diameter registered fit there, so I'm just doing that to kind of make a witness mark. Just like so. Let me make sure I have my feed set up. I've got that feeding slower now just so that I can sneak up on that where I want. Right there. I'm going to take the remainder, so that's only a 30 thousandths fit on there. Getting that right. Too slow of a feed, that's why we're stringing up chips like that. Now before I do anything, I'm going to go ahead and reset my 0 over here on this dial indicator, because now we've got to turn about 50 thousandths off of that. This is one of our more critical dimensions that we're trying to shoot right here. So use our calipers and see where we're at. Yep, 2-inch 48, so we want this to be 2 inches. And one of the radiuses that I had on our print, I've got it, let me see what I put on there. I put 1/64th radius on there. And even that's really not accurate because we're using a 1/64th corner radius on this insert tool. And that's really the only reason why Justin had drawn that on there, because he knew that there was going to be a nose radius, but he wasn't sure what it was. So that's why I just kind of changed it to make it a little bit smaller. And whatever that corner radius is what it's going to be on the part right there. I'm just going to turn this by hand. Use our Starrett digital calipers for this reading here. There's just so little that you have to measure. Let's see if we can hit it on 2 inches as close as we can. That's 17 and a half. So it looks like 17 and a half is what we need to take off there. Take another 10. And then let's measure it one more time. I'm getting 7.5, so that's what we're going to go with. The sleeve, the center section of it, will have a couple thousandths clearance, so it'll fit over that register there. All right, 5, 6, 7.5. I can catch it right again. 199.9995. I think that's going to work just fine. 2-inch that time, so I think we're good on our register fit there. We're getting into the trickiest part of machining these parts here, and that's getting up inside that face like that. So the tool that we really need for this operation is a face grooving tool. Looks very similar to this right here in case you haven't seen it before, but the way that they're designed is that the bottom of the tool here that supports underneath the insert actually has a radius to it, a curve, so that it matches the radius of the part that you're machining. If we come in here with this tool, which by the way, this is the tool that we're going to be using, but I think it's going to work because we only have to go 25 thousandths deep with this. So I'm thinking that we're going to have enough material, we're going to have enough relief underneath the insert that I can plunge that tool in there, you know, that we need to go 25, 30 thousandths, and it shouldn't rub. If it does rub a little bit, what we can do is take this out and I can just go ahead and just grind a little bit off the bottom of that tool if we need to. Obviously you don't want to take all this away because then you're removing the support for the insert, but if we need to just nib a little bit off that bottom corner there, we can do that just so that we can get in here and machine that as we need to. But I wanted, since we're only doing this part right here and this is what I got, I'm just going forward with it. The other thing that you can do obviously is this is a good case where you're using hand ground high-speed steel tools. That's what I've used a lot in the past, and I got drawers full of them at the home shop. But I want to use my carbide tools for this right here. So I'm probably going to go ahead and invest in a couple more. This would have been a good case to have a right-handed grooving insert, grooving tool there as well. And that's why I'm on the back side, because we can get right up next to this shank right here. You can see if we come over here to this side, if we're turning it like we normally do, I just can't get up in there. Now I can turn this on an angle and get in there and cut that, but it's probably not gonna give me what I want out here. So I think we're just gonna go straight in with it on this opposite side. We'll run the lathe in reverse and we should be able to come in there and plunge that little undercut on that face. Get my 0 on my Z here. We're going to go ahead and plunge and see what happens. All right, we're starting to get into our the bottom of our tool there, and that's right at the depth that we need to be. That's looking good though. I won't need but another 5 thou, but it won't go any further because it's touching that shank of that tool. We'll go ahead and try to relieve the rest of it here. Hand feeding. To my 0. Pretty good. I come back here. Going in another 5 thousandths because that's what I needed. And then we'll finish facing this out again. Back off because the bottom of the tool on this side is trying to rub, so I'm going to take this out and we're going to relieve a little bit of that bottom so it's not hitting down there on that face. I got to thinking right then, I've got this MX22 threading tool with 1/8 wide grooving insert, full radius insert, which is the same thing that I'm using right there. I think I can get in there with this tool and do the same thing. It's already got all the relief built into the bottom of it, so I don't think I have any problems with it rubbing. So I'm going to take this grooving tool out. We're going to put this guy in there. I think this is going to give me exactly what I want to do right there. All right, let's try it again, see what we can do with this tool. Nope. Oh, you know what I did? Ah, dumb mistake. I was running it in the wrong direction there. My fault. Well, there goes that tip. Let me go ahead and change that around and we'll try that again. All right, one more time. Here we go. Reverse. There we go. Feels much better. I'm just going to come out to that outside diameter and just blend it. Okay, let's go to the inside. Yeah, see, we still got to turn that down. That's why I left that. So it'll be easier to get in there and finish that inside corner with that tool. Go ahead and clean that face up one more time and just took 2/1000ths off of that. Okay, yeah, that worked pretty good. So now we can go ahead and finish this diameter here. When we finish this diameter, we can go ahead and get that inside radius there as well. We're going to go ahead and finish turning this down to our 0.75 diameter. Got about 40/1000ths to come off. And I've got a Z set there so that when we get up there close to that shoulder, it's going to give us enough material to clean up using our radius tool, clean up that corner with it. It's just 20 thou pass there. We'll turn it, mic it, and then take our finished cut. All right, that's going to be where the radius will start there. So I'll tell you what, we'll go ahead and kick this up one more gear. That's going to be 1200 RPM. And where did I set my micrometer? Here it is. Go ahead and take one more pass here. Let's see where we're at. 21.5. That works, 21.5. So I'm going to dial in 20. Hopefully that'll leave us just a little bit oversized and we can hit that with some memory and make sure it's good and smooth. 10, 20, there we go. Yep, there we go. A little bit better surface finish with that speed on it. Up to my 0 right there. Okay. Okay. Yep, so we're about a half a thousandths oversized, so we'll be able to hit that with our emery paper there. Plus it's still a little bit warm. It'll probably shrink a couple of tenths there as well. So now we just got to go ahead and finish that radius there, and all this will be done. And after that we can put our hole through it. That should be it. Looks like it's blended together pretty well. We'll just hit everything with our Scotch-Brite and that should be good to go. We'll go ahead and break those two outside corners there. This one I just want to break it. I don't want to take much. About like that, just get rid of the sharpness. Okay. Okay, so next up, we're gonna go ahead and put our hole down through there. So this is gonna be a 3/8 diameter hole. It's simply a hole for a bolt to go through. I'm gonna start with this 3/8 diameter split point. This is one of the reduced length drills just to kind of get our hole established, try to keep it nice and centered. And then we'll swap it out with our standard jobber drill to finish going all the way through there. We'll use some anchor lube for this cut here. We're going to go ahead and get this polished now. Go ahead and check our diameter again. Yep, still slightly over. Just going to give it a polish with some emery right here. And then I've got some Scotch-Brite. I'm going to use our Scotch-Brite. I want to soften up that corner where that little register fit is. Go ahead and polish this up a little bit too. Make everything look nice. That should be it. Let me see where we're at on our diameter. That is looking good. Yep, that is looking good. So this side of our part is now finished. So from here we need to take this out. We'll have to chuck it on this side and finish facing the back side to the proper thickness. Got that looking good. I'm gonna go ahead and take it out of the chuck. And what I want to do is go ahead and just clean all this dust off of here. So we're just going to chuck it like that. I'm going to do a little bit of measuring first, but we'll just put it in there and chuck it. Face this back side off. Transfer those outside and inside corners and we'll be done. All right, let's go ahead and get it chucked up. So we've got about 200 to come off of that face. I cut it thick because I wanted to make sure that I had enough material to be able to hold it to do that first operation that you saw. Go in there as far as we can without getting on the radius, so right about there. And I don't want to over tighten it But we'll go ahead and snug all three of the pinions again, kind of equalize that on the scroll, and we should be good to go. All right, well, we got our first part completed there. I think it turned out pretty good, looks good. It looks like it matches up to our print pretty nicely. So there we go, one down, two more to go. So next up, we'll go ahead and work on the center spacer there. Get started on that one next.